Hello, everyone. Welcome to part 3 of Machine Learning Best Practices on Digital Hub series. These are hands-on sessions that we work on real-world use case and develop expert notebooks for you to go through an end-to-end methodology from getting the data, developing your model, and also visualizing it to communicate it with your stakeholders and report it. But before we move on to the presentation, let's please notice our legal disclaimer. Material presented here, including but not limited to text, images, and codes, are subject to Digital Hub terms and conditions and are for demonstration purposes only, and may include future product features and plans. Sharing, copying, reproducing, and modifying them in any form requires Integra's permission. I am Hodar Rezai. I'm your host today. I also have Babak Shafi, our founder and CEO, with me, and also Sylvia Lee, our data scientist, which is going to do the demo. Please mark this date on your calendars for our upcoming webinar. On July 13th, we were going to have the essential data skills for engineers. As a lot of people are transitioning to data science, we are going to help them grow their skills. And first step is to kind of the data exploration and data skills. You can register for this event on our website, on our LinkedIn page, and we are also on Eventbrite. So make sure you mark this and you join us for this event as well. Now, because this is a hands-on session, you will have a chance to follow along Sylvia when she's doing the demo. You need to be registered to Digital Hub. And for that, you need to create your account on the platform. You need to subscribe to a plan. We have 3 different plans, which the academia plan is free for students, and we are also offering it for free using a promo code to our webinar attendees. And when you're subscribed to the plan, you need to create a project, either a data exploration or machine learning project, and access the notebook. Look for the model validation notebook. That's what we're going to present today. And please make sure you flag our emails as trusted on your inboxes so they don't end up in the spam folder, because we're going to have like important communications regarding your account, your usage, and also some promotions. Next slide, please. And with that, I'm going to hand it to Babak for an interview of Integra and Digital Hub. To you, Babak.
Hello, everyone. Good day. Excited to be here as part of part 3 of this machine learning session. Quite exciting day, and what we're going to show you on energy optimization. A lot of the techniques and capabilities can be transferred to any other use case, but we specifically use this because a lot of the oil and gas operators also have energy production, and we wanted to show them or show you a way how everybody can save on energy based on the market prices and deciding what energy output they could put out, and what if they should buy from the grid or they should sell from the grid. These are all really critical business decisions that most people actually don't think about, but it can save millions of dollars. And we're going to use actually power plant data that we have and demonstrate that how, for example, using market data from AESO would have impacted the energy production, because you always know how much energy your plant needs based on your average usage, and turning up if you have a gas turbine or you have any other sort of electricity generation capability, turning up and down the megawatts is not that complicated. So having a dashboard like what we have today that we're going to show you, and understanding how the models work, would be a fantastic business tool to save you guys millions of dollars. So with that said, if you're an engineer, you're going to look at the concepts. If you're a data scientist, you're going to look at the stats. And if you're a business person or a business analyst, look at the savings that this will bring for you. And really, that is the introduction of Integra. That's what we're here for. We're here to reduce the barriers to adoption of AI and ML. These examples and these use cases that we put out there are to show that, hey, it's not that complicated. And we do have the platform and the capability to walk you through those steps. As an individual, our goal is to enable you, because we understand, and the community that we are, it can be just us or a few big vendors who are going to move this needle. It's going to be every single one of you who is on this event. to learn and then use some of these techniques. And you don't have to go spend years educating yourself on all kinds of courses. If you have, some experience with data and some basic understanding of Python, and with these procedural and expert notebooks that we have developed, we can just follow the concept and reuse some of these concepts. So make sure that you join our community, sign up to the platform, support us so we can make more of these templates for you. And if you like it, let us know. So because we're trying to get an understanding of how complex some of these templates should get or how simple. And in future, I think we're going to go back, these are some of the complex ones and get back to some of the basics. So if you guys are more on the entry level in terms of learning data science or transitioning from engineering to data science, you have all the tools that you need to move on. If you're a business on this call, please reach out. We do offer our own kind of guiding and consulting and services that we'll be happy to bring in our expertise. And Sylvia, great data scientist, and Hoda and myself, work on some of the problems or help you guide you through that process. So we are open for business. Next slide, please. So Digital Hub, if you have joined us before, you know what Digital Hub is. Make sure you get a plan. We're doing lots of promotion these days. And what Digital Hub does is it's out of the box tool, very cost effective. You basically, when you use it, when you are turning on the projects, you get built. And if you don't need it, you can just stop it. And lots of these expert notebooks that one of them will go through today are on Digital Hub, and we continue to develop it. It's online, it's cloud native, very modern, and it gives you access to a numerous set of tools that you will see some of them today. From machine learning to data visualization to data engineering to building pipelines, doing predictions, all of it in one place. It's a platform that I wanted as an executive back, when I was in the corporate role, and it would have cost millions of dollars. But we brought this for like a few dollars. If you can afford to have a coffee every day, you can afford to have a plan on Digital Hub. Next slide, please. Who is it for? So specifically engineers. So lots of my friends are engineers, our colleagues, neighbors around here in Calgary are engineers, and they're transitioning. And they're transitioning to data science for multiple reasons. Some of them are transitioning on the job. They're trying to learn, and some of them are transitioning because they're out of the job and they're available in the market and they're trying to go into a different industry. Most of these engineers have good data hygienes, have good data understanding and business process, but the tools that they've been taught either at school or they've used in aging infrastructures in oil and gas companies are not that modern. The Digital Hub will give them those capabilities. So it's basically using the same skills they had in the new setup tool set. Data scientists, they spend a lot of time configuring packages, setting things up. Digital Hub comes out of the box, is ready to go, and we're continuously updating it. So they will save lots of time in terms of managing the packages and customizing the environment. And plus, with Digital Hub, unlike big vendors, you don't need to actually know a lot of IT. You just go in and create a project and boom, it works. And it's very simple to implement if you're a small business or large business on your own infrastructure as well. The business analyst is another group. We wanted to bring in these three people as a center of excellence together to work together on solving the problem. And collaboration is one of the key features of Digital Hub. Okay, next slide. So I'm trying to make these introductions shorter and shorter and go as fast as I can in order to give Sylvia more time for all the exciting and the good parts. So with that, I'm going to hand it to you, Sylvia.
Okay. Thank you, Babak. So we're actually going to get started with the demo now. So just as a quick preview, throughout this series, we have gone through different aspects of machine learning. So first, how to get on with best practices with Git and Conda, how to do the feature engineering process, and introducing the general framework for hyperparameter tuning. And so now we're at the final part of our machine learning process here in terms of how do you validate your data model, making sure that you don't have any significant problem in bias variance, or how do you compare two different models to decide which model is better. And then so what we're actually going to do is that we took it a little bit step further, is that once we have validated our data model, we're going to make a predictions and then combine it with forecast data, market forecast data, to generate the market analysis, and taking those analysis results, put them into visualizing and dashboarding applications called supersets in terms of how you can visualize it and actually generate business value out of it. So with that, I'm going to head over to Digital Hub. But just a quick mention here with the previous webinar series, you can also see them on videos on our inside Digital Hub and also on our YouTube channel for review. So just give me 1 second here as I navigate over to the browser. So as always, you can find us on cloud.digitalhub.io. Once you've put that into your browser, you'll be brought to our sign-in page here. If you don't have an account with us, feel free to come in and sign up. And then it will just be your emails and password, username. And then so once you've signed up with us, you can come in and sign on. Just gonna sign in here into my account. So once you sign in, you will be able to see the dashboard here, our brand new homepage. So then again, the tutorials here is where you can find some of our previous webinar series. We also have a few blogs here that we've written in the past that would be interesting read for you in terms of this data space. So what I'm going to show you is Hoda mentioned that we do ask that you have a subscription with us in order to create projects on here. So how you can do that is to navigate to the subscription and pricing page here. In this case, I have a team subscription, but you can come in and subscribe for the academia plan on here. Just click into the select here. You'll be brought to a page where you have to input some of your informations, and then there'll be also a box for you to input that promotion code. So that's how you can get this free academia plan with us, just as a promotion for our webinars attendees here. So once you have a subscription with us, you can come in and actually create projects. So how you can do that is just to navigate into the develop section here, create project. It's a very simple 4-step process. I'm just going to show you quickly here. So you can do, so I'm doing machine learning this time. I'm gonna go into machine learning here. Choose your component. So Superset and Grafana are visualizing dashboarding applications. H2O here, this is an integrated environment that we have with Jupyter Lab. So Jupyter Lab, but with H2O integrated. So let's say I'm going to choose all 3 of them. If you're a Teams role, you can add members. So in this case, let's say I'm adding Hoda and give her a role inside the project. This will actually propagate to all the applications and give them that corresponding role as well. Give it a good name. So I'm going to call this my machine learning project. So to say this is energy. So let me find it later and create. So with 4 steps here, your project is now being submitted into a backend and it's going to get provisioned. So what it's actually doing in the backend is that we're launching up a specific projects database for this project. And through that database is how your applications all get connected and integrated together. Do note that on here, once it's finished provisioned, all of your instances will be up and active, running on the cluster. So then that's where your hours is going to start counting. So if you're not going to use your applications, do remember to come in and post them so you don't spend any unused hours and waste them. Also, again, as Oda said, do look out for emails because we do send out emails in terms of your usage that we're counting and some warnings as you're approaching your limits. So do also look out for those as well. But for time's sake here, I already have a project in which we're going to go in and look into our notebooks here. So I have a power plant predictions. I already launched up my superset and my Jupyter Lab just to save up some time here. I can get to my tab. Okay. So I've already launched up Jupyter here. So it's Hoda said, you can follow along on the template notebooks. So what you're going to see here is that once you have come into Jupyter, go to your launcher here, click on template, select Digital Hub template, and you'll be able to see the DHML model validations. So then with that notebook, you can follow along with us. So in this case here, I've already pre-ran some of this notebook just to save up some time. But what you're going to see in this notebook here is a quick introduction into a use case here. Again, this will be the electrical generations, and then we're going to combine it with market data that we get from AESO, join them together, and then do a market analysis to come up with different recommended actions. Again, we're loading in the Lucara libraries. We're doing data exploration with pandas profiling. There's a little bit sections in terms of data splitting and how that is an important step in your machine learning in terms of validations as well. But we do have resources in there to provide you a little bit more information on data splitting. We have gone through these in previous webinars, so I'm not going to go into them in details here. So again, the feature engineering process inside the notebook here. We also have a separate notebook on feature engineering from previous webinar where it's as explained in a little bit more details, and also with the parameter tuning. So I'll go ahead and run those in the notebook, and then just to navigate and see what they brings up. So with the pandas profiling here, look through your variables, your correlations. With the market data, see how we parse them and join them with the time here. Again, a little bit more on data splitting, data engineering process in here, and also the machine learning building and how we came up with a optimized model after hyperparameter tuning. So a lot of these informations are from previous webinars, so feel free to go back to them, to those videos to go through them or to look at the different notebooks. I have reference to those notebooks that you can go back to. Those are also inside the template notebooks that you can just spin up and run. So in this case, for the rest of the validations, we're going to majorly look at two different models here. So I have already transformed my data with my transformation pipeline. What I did is I put them into a baseline model, which is just the default support vector model from the scikit-learn package. And then I have an optimized model where from previously when we did our hyperparameter tuning, we did come up with a few hyperparameter values that gave us the best scores. So I'm going to use that optimized model to come up with a final score that we can do a validations and do a comparison between these two models here. So in terms of model validations, the most simple type of validations is having a holdout set and then doing a score on that holdout set. So what that means is that when you split your model, you're going to reserve a portion of your data that you're not going to touch until the very end. And then so that is usually called either the validation set or the holdout set. And then because these are data that your model have never ever seen before, that's why we can use them to kind of validate whether how well your model generalized or like if your model is going to have introduce any sort of bias, any sort of underfitting or overfitting problem. So this is kind of the most basic form of validations you can do. So scoring my base model and my optimized model on this holdout set that I have, I can see that the base model is 0.92, where my optimized model is 0.93. So then this is kind of sort of the validations on how good your model is in terms of generalizing. If you compare this validation score with your previous training test or cross-validation score, and then seeing how far it differs, that kind of also gives you an insight into if your model is doing any sort of bias or variance problem. Another validations that you can do is a comparisons between different models. Say that you have trained up a bunch of different models and you want to see which ones are better than the other. In addition to having the validation score, you can actually also do a statistic, a statistic testing to decide if your model scores are significantly different from each other. Sorry. So in this case here, we've introduced to you a model called the Wilcoxon test. Can read a little bit more here, but what it basically does is that it uses cross-validations to generate a sample of scores for each of your models, and then applying a variation of the t-test, the pair t-test, to come up with a p-value for you. So that as with any statistical test, if your p-value is less than your 0.05, which is our significance level here, we will reject null hypothesis. in which in this case, the null hypothesis is that your models are not significantly different from each other. So with our p-value here between our baseline model and our optimized model being 0.04, we could kind of conclude that like they are significantly different from each other. And with the information that we've just got on our validation score, I can say in here that our optimized model actually is doing better than our baseline model. So that's a comparison between the models. Another evaluation you can do is on the residuals itself. So the residuals is the difference between your predicted values and your expected value. So that residual analysis here, what it majorly does is give you an idea between your bias and variance of your model. So what you will want to see in your residuals is that all of them basically is clustering around 0 randomly. If you see any sort of trends or any sort of big variations, that's usually the indications of something's wrong. Another sort of visualizations that you can do is looking at the histogram of the residuals and also the QQ plot. Again, one the sort of normal distribution around 0 here, and we want to see your QQ plot and your residuals lying very close to the expected line. So in this case here, for our model, for a few outliers in here, I think about 3 outliers, where it's doing a little bit worse. Overall, our model is not doing bad. I would say this is a relatively good model already for predicting the energy output here. And of course, the most simplest is you can also always do a expected versus your predicted plot to see how far they deviate from each other. So that was a very quick introduction to model validations. So I'm going to take the rest of the time here just to take our machine learning here a step further and then combining it with market data to see how we can generate some market values out of it. So again, we have the forecast data from AESO. So what I did in here, I also had a week of data that our model have never seen before. So this is outside of the validation set, outside of the training set. So this is kind of just imitating in the future. I have a week of data that I want to predict on. So then once I have put my data into my transformation pipeline and put it into the model for predictions and getting my predicted models out of it, I join it with the forecast data from AESO. So you can see in the table here. So it's kind of my predicted output and also the forecast price for that hour. And then we have generated a sort of simulated a internal load for the then energy output data. So then just imitating kind of the scenarios where you have the power plant and you have a internal demand that you need for that power plant to operate. So then now I have the internal load here that is simulated for that hour income, and then also our forecast price and also our predicted hourly output. So in here, what we're actually going to do is to put it into a very not general, but a relatively straightforward logic in here, where if we compare our production cost and the grid price that we get from the AESO, we have a few scenarios here. So if our production cost is going to be higher than the price for the market, then of course we're going to buy what we need, so the demand load from the market, from the grid. Or if our production cost is less, then like we have 2 scenarios where we might have predicted a production shortage. So we'll produce what we can and buy what we need from the market. Or you have a production surplus where you're going to produce the full cost and then actually sell back to the market to make back some money. So just a very simple logic here in how you can pick the forecast price and then also your predictions from your machine learning model, and then to generate some recommended actions. So I've created a data frame here that you can go through, just sort of through like the different calculated values and how it generates the recommended actions at the very end here, and also your estimated net cost if you follow the recommended actions. And again, you can of course do some plotting inside the notebook here with the Python packages. So just created 2 plots on here for you to take a look, showing the hourly production surpluses and shortages, and also the net cost and their corresponding actions. But these are inside the notebooks, and you can't really ask operators to run a notebook every single time. They want to see what are the recommended actions and the insights out of it. So what I'm going to show you next in here is actually how do you get the data here now from the notebook into a dashboarding application. So in this case, we're going to use Superset. So as I've mentioned before, for every single project, there is a database that acts as your central source of the truth that connects all of your applications together. So inside this notebook, what you're actually going to find is how to connect to that database. So for all of the Jupyter Lab instance that you are on, you're actually going to be able to see all of your database URI inside your environmental variables. So you can execute this command here inside your terminal from the launcher to see the list of URIs. But generally, what you're going to see is a list of variables that's in this format. So DB, your project's name, URI. So that would correspond to the database for every single one of the projects that you either you created or you're part of. I've commented it out here, but then these, as you can comment them, this is how you are going to be able to actually connect to your database through the notebook here. And then in this case, I have imported 3 of our data frames here into the database that I'm on. So these are the 3 data frames. One of them with the just the machine learning validations, to predict energy and the residuals, my energy predictions, and also that final markets analysis result that I have. So what you're going to see here is also quick functions in terms of how to inject your data frames into the database, and then also how to just terminate the engine. So now with the tables already inside your database, now you can head over to your dashboarding applications like Superset and Grafana to visualize the data and create these dashboards. So for the purpose of the demo, I already have them ingested, so I'm not going to run these cells here, but this is how you can get your data into the data frames there. So I'm going to navigate over to Superset here now. So this is also a dashboard now that we've created for that market analysis. So before I walk you through the dashboard in here, I'm just going to show you quickly how to actually get the tables. So what you're going to see in Superset is a source tab here. So in the source tab, you can see that you have the database. So the default database, this is the database that's connected to the Jupyter Lab and also to Grafana if you have that deployed. And under sources in here, again, what you're going to see is the tables. So what you're actually going to need to do, in this case, I already have the tables in here, but for the tables that you have ingested into your database, you need to also add them to Superset here. So you can just quickly create a new record in here inside the tables, and then put in the table name for that data set that you have ingested for Superset to know to refer to those data tables to get their data out of it. So from there, you can now use the data sets inside your database there to create these beautiful dashboards. So what I've actually done in here is actually just created some numbers in terms of what is the optimized cost. So if you follow the recommended actions, this is going to be the cost for these are weekly. So for that week, what was the production cost if you ignore the recommended action and just produce to your full load for every single hour? And what's the estimated cost for if you, again, don't listen to the recommended actions and just buy everything from the market? You can already see here from the optimized cost, you're actually already saving millions of dollars just in a week. If just going according to the recommendations actions there instead of buying everything from the market. Then again, we have the estimated total energy output for that week. Can also take that energy output and create a nice little plot here with the number here showing what's your latest value. So this will be the energy output on the latest hour here. So over the week, how many times you have a surplus, how many times you have a shortage in terms of your productions here. And also this is the recommended actions by the day. So for every single day in that 24 hours, how many times did it recommend you to buy your demand from the grid? How many times did it recommend to you to produce your full load and then buy your shortage from the grid, and how many times it recommended you to produce your full load and sell your service to the grid. Also, 2 more time plots on here just to show a quick comparisons between the cost for if you listen to the recommended actions, call it the estimated net cost here, and also if you just produce for full, if you without listening to the recommended actions. and also time plot here just to showing what was the surpluses and shortage throughout that week at the hourly timestamp. So these are just some of an example of what you can do by taking your results from your machine learning model and applying it into a logic and then displaying it onto, this is actually kind of like a business intelligence tool here for make it applicable and accessible to engineers and operators to make decisions. The beauty of this is that if you have your machine learning model running real time, your dashboards can actually get updated real time as your database get updated. Say if you're making predictions daily or hourly, as long as you're making those updates daily or hourly into your database, your superset dashboard here, they would also update in real time accordingly. So that is right now a quick example of what you can do. And I see that I'm already at the mark for the webinar series, so I'm going to hand this back to Babak.